Hello everyone, we're sitting here with Robert. Hi Robert. That's Robert, one of the happiest men on the planet.
Mr. Bibb?
I'll take one to go.
Okay.
All right, thank you.
That's Robert, one of the happiest men on the planet. Make that face again, Robert. Yeah, he said that he's one of the happiest men. Because you just had dessert, right, Robert? You just had dessert.
Tastes like chicken.
So I was showing Robert this idea here about an experiment I want to do. And I want to, so let's say the center rod, I don't know if you could see it in there.
He said rod.
This center rod right here, that is a magnet. And this is the blotch wall, right? So I want to move that blotch wall. When the blotch wall is moving, now study Mr. Blotch. Blotch was a Nobel Prize winner, if I recall correctly. He's a very knowledgeable man. And we have another Nobel Prize winner, which is Richard Feynman, who also taught at Caltech, who says that in a cubic centimeter of space, there's enough energy to power the whole planet. I'm paraphrasing. And that energy replenishes itself at 10 to the 120th times per second, so it can just keep on going. So there's plenty of energy in space. And magnets, when we look at Donald Lee Smith, he talked about magnets, and if I understood correctly, magnets are basically supercharged by electrons being arranged in a certain configuration, which I'm not sure that's completely understood yet. I certainly don't understand it yet, but electrons coming from the sun, right? Electron pairs. So if we have this rod here that's a magnet, and the blotch wall is here, and then this is an electromagnet right here, coil.
Yeah.
And this coil is going to be powered by a 12-volt battery right here, right? This is a 12-volt battery that powers this coil. And Robert said to use a 555 timer to pulse that coil on and off, on and off. And those pulses are going to cause this blotch wall, which is the neutral point of a magnet, so the north and south, and then a strong magnetic field here should pull this, depending on what way this coil's wound, right? Which way the polarity is, will cause this to either the blotch wall to move this way or this way, right? Another way of thinking about it is if I had two of these rods, these magnets, and if I had another one right next to it, and I connected it together here with south and then north on this side, this blotch wall would move to right there, if I understand correctly. That's my research and study indicate that. But rather than doing it mechanically, where I actually physically place a magnet there or spin a magnet there or whatever it may be, I want to use an electromagnet coil and pulse it. And then this is a separate coil, right? So as this is pulsing, if this blotch wall moves, right? If it moves this way, or moves this way, or moves both ways, depending on maybe if I switch the polarity, if this polarity could be switched back and forth, right? It might push this blotch wall this way and that way and this way and this way and this way and this way, right? And then I'm going to take that power. Okay, so then what happens is, if I understand correctly, and this is a thought experiment, I'm interested in extracting energy directly from magnets, right? So the question is, when these flux fields are moving, is the output, meaning the output from the magnet, the flux fields coming off the magnet, if that is what's happening, are those greater than the power going into the coil, right? That's a question. So my question is, and Robert asked me, he said, what's happening here and what's happening here? Well, this is the battery I want to charge. This is a 12-volt battery as well, right? This is a 12-volt battery as well. But the question is, can this battery recharge faster than this one discharges? That's the question. This is a full wave bridge rectifier. I don't know if we would need a capacitor also here, but at first I would want to just put a full wave bridge rectifier and then go directly into the battery. Anyway, that's today's thought experiment, and Robert called this what did he call this? A permanent magnet transformer. That's what Robert called it. He said, oh, it's a permanent magnet transformer. So that's today's thought experiment, and there'll be more to come. Okay, everyone, have a great day, and make your video responses to this, sharing your thought experiments as you wish. I'll be interested in watching your videos. Okay, bye everyone. Want to say bye, Robert?
Adios. Ciao.
Okay, Robert says bye.